Friends, welcome to s.mathguru classes. Today we consider one new topics, new unit, new portion. All of these are new. This is all of you know the topics is Jacobians. Now what is Jacobians? We have to know definition of Jacobians, how to find Jacobian, how to solve Jacobian. We want to discuss all of this, and this is very interesting, very easy, very nice. All of these are very interesting. Now we are using a magic. By using this magic, the Jacobian will come. Jacobian will come. So the definition is this: if u and v are functions of two independent variables x and y, then the determinant del u del x, del u del y, del v del x, del v del y is called Jacobian of uv with respect to x and y. Independent variable x and y is written as del uv divided by del xy, or j, Jacobian j u comma v xy. This one our symbolic form. If del u comma v del x comma y we have, then we write first, in first row we write u because u is the first position. Del u del x, del u del y, we write this, and v del v del x, del v del y, we write this one. Or similarly here also del u del x, del u del y, del v del x, del v del y. And if we get three variables, similarly the Jacobian of u v w with respect to x y z, we write del u comma v comma w by del x y z, we write this. In first row u is first, x y z we differentiating with respect to x y z, and v in second and w in third row. So this is our Jacobian. This is the definition of Jacobian, and we can easily solve any kinds of problem by using this Jacobian's rule. This is very easy. We consider one Mosty problem. The Mosty problem is that if x equal to r cos theta, y equal to r sin theta, evaluate del xy by del r theta, or del r theta by del xy. Very nice solution, this one. Problem is easy, solution also easy. Now here x equal to given r cos theta, y equal to r sin theta. First we find del x del r. This is del x del r and r cos theta. This will be r cos theta is outside because we differentiate partially with respect to r is 1. That means ultimately we get cos theta we get. Del x del theta. Del theta r cos of theta. Then r is constant outside. Ddx of cos means minus sin. This is minus sin theta. We get this. So x is finished. Next we consider y. Del y del r. Del r r sin theta. And r is 1. Sin theta is constant. Del r 1, and we get this is sin theta. Del y del theta del theta, this is r sin theta. R outside, then we differentiate with respect to theta. Del theta of sin theta means cos theta. We get these are the values of del u del r, del x del r, del x del theta, del y del r, del y del theta. Now we have to find this one. Now del xy by del r theta, this can be written as, by definition of Jacobian, del x del r del x del theta, because X in first position, we write del x del r, del x del theta. This. And del y del r del y del theta. This one. Just by definition of Jacobian, we can write this. Now putting the ready-made values, we know the values. Del x del r. Del x del r means cos theta. Del x del theta. Del x del theta means minus r sin theta. Del y del r. Del y del r means sin theta. And del y del theta means r cos theta. We get this one. We get this. Now we expand this determinant, ultimately we get the required value. This into this minus this into this. So cos theta dot r cos theta minus this into this. Sin theta minus r sin theta. Just this into this minus this into this. By rules of determinant, we can write this. And these are cos square theta, r sin square theta. R common, we get cos square theta plus sin square theta. And r into 1. Cos square theta plus sin square theta, we know 1. So what we get, therefore, del x comma y del r comma theta, this equal to r. This is the first answer we get. We get the first answer. Next, our requirement del r theta by del x y. Since now second part you consider. Second part. Since del xy del r theta into del r theta del xy, obviously this will be 1. This cancel, ultimately we get 1. But this value just we get r. Del r theta del xy equal to 1 we get. So this implies del r theta del xy, this equal to 1 by r. And this is our answer. Very nice solution, very easy, very interesting also. There another problem of the same types. Find the Jacobian J u v x y for u equal to e to the power x sin y and v equal to x log of sin y. Now we have to find Jacobian of this. Now solution is that what are given here, u equal to given e to the power x sin y and v equal to given x log of sin y. This one given. First we find del u del x del x e to the power x sin y. We get this. And this will be e to the power x. This is sin y constant because we differentiate partially with respect to x. So we get del x of e to the power x. And sin y, ddx of e to the power x means e to the power x. So this will be e to the power x sin y we get. Next, del u del y. Del y e to the power x sine y. E to the power x is constant outside del y of sine y. E to the power x cos y we get. ddx of sine means cos. So u is finished. Next we consider v. Del v del x del x x of log of sine y, and log of sine y, this is constant, this will be outside because we differentiate partially with respect to x. So x is variable. So this will be log of sine y del x 1. So this is log of sine y. Del v del y del y x log of sine y. This is x del y log of sine y x. This is ddx of log means 1 by sine, 1 by sine, and ddx of sine means cos. This is cos y, and this will be x cot y. We get this one. So we have del v del x, del v del y. Now our requirement this one. Now Jacobian u comma v x comma y. By definition we get del u del x del u del y del v del x del v del y. This is our definition of Jacobian. Now putting the ready-made values, the values are del u del x. Del u del x means e to the power x sine y. Del u del y e to the power x cos y. Del v del x log of sine y. Log of sine y. Del v del y x cot y. We get these are the values. Now expand this into this minus this into this. So if we expand, we get x e to the power x e to the power x sine y into cot y, sine y into cot y minus this into this e to the power x cos y into log of sine y. We get this one. So this is x e to the power x remains same, sine y also remains same, cot means cos by sine. We get this. And this is remains same, e to the power x cos y log of sine y. Sine y cancel, x e to the power x cos of y e to the power x cos of y log of sine y. And we taking common e to the power x cos y common, and e to the power x cos y common, we get here x and here log of sine y, and this is the final answer of the given problem. This is the Jacobian, this one. So dear student, whether this problem is musty or not, very interesting, very easy and very simple also. So I hope you are all enjoying with me. If you are enjoying, then please like this video And if you are new in my channel for getting new videos at the very beginning, then please subscribe my channel and click the bell icon. Thank you.